the next step is to create our schematics. In order to do that, we go back to our project, right-click, add new to project, schematic. And now we have to add all the parts that we have created before. Adding parts is fairly simple. You can either right-click and select place part, or over time you want to do it a lot faster, so you just press PP or place part. You can choose them, you can get them from your parts library, and here you can see the different files or different parts that you can choose from. You will notice that I added a couple of more resistors to our device. We have here our microcontroller, which has a nice U question mark here, but if you click on the push button, I actually forgot to change its designator. So let's first go back and actually clean up that library. We go back into our parts library, into our symbol here. We double click on it. And for our push button, what we want to say that this is an SW question mark, and we don't want the default comment, not necessary. We don't need the supplier itself. We save it. We check that these have the C's, that's all right. LST is a diode for the LED. We don't want this visible nor this visible. We save it. The MSPB checked, and these two are fine too. Okay, let's go back to our schematic. Let's save our schematics. Let's call this homework 1-2. And PP place a part. We choose a switch. Let's just place it here for now. We want to place another part. We want to place the MSP430. Let's add a few LEDs. Actually, down here, it added even more switches. And let's add that's it. All right, first for the switch, actually let's start with this one here. We see we have twice the part number, and that's because we have the comment in here and the actual part number. We don't want that. Let's first wire this one up to power and ground. So we click up at the top here. We get a VCC symbol for power, and we have a power symbol for down. We press place W for wire, and with the wire we can connect that. You can also hold a part and move it around, and that way it won't break the connection, or if I just click it, it will actually break the connection. If you hold down Control while moving it, the connections will be extended. Next, let's add the switch. We add a wire to one of the pins. This will be the pin that when we press, there will be a different signal over here that happens. And what we want to do is that the pin is by default high. So let's add a pull-up resistor. Let's choose a 10K pull-up resistor that we add in here. So by default, if we connect this particular pin here to power, this is open, so this particular pin here will be pulled up high using this 10K resistor. And if we connect the other side to ground, as soon as we push this button, this node here will be pulled low, and that's what we can register on this particular I/O line. We will see that the line goes up and down. Next, we want to add some LEDs to our circuit. And for that, we need some more resistors. this case I choose a 330 resistors. That should give us a decent illumination. And what I just noticed is that I have them all I need to flip them around. Again, you rotate things by pressing space. Feed a wire through all of them and then connect them to power. Copying a part is very simple. You just hold down Shift, grab a part, and that will make a copy of it. Next, we want to draw little offshoot lines from it, and I could of course just connect them now over to the pins, but I want to show another way of connecting things to a part in case you don't have as nice of a space like here, or the schematic starts to become complicated. What you can do is you can place a net label, or PN. Let's set one here, 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 and here, and we set one here, 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 and here, and we can now rename them. Let's call this one LED1, LED2, LED3, and LED4. Again here, LED1, and you can see how Altium actually now sees the net labels that already exist. And what this makes is that connection, the network is from LED4 to LED4, so these two lines are actually connected in the logic behind the whole device. So there are a few more lines and things that we need to add to this device, and we want bypass capacitor on the power line. So let's add some of these capacitors that we created. More specifically, I want to add a 10 microfarad capacitor. And I'm adding another 0.1 capacitor in between. As always, you want to make this look nice, so you can actually read the things. It's at the end, it is a standard for you to remember later on what you actually wanted to do and what you wanted to create. And this is why we really place bypass capacitors right to the power pin. This way we know, okay, these two capacitors have to be physically close to this power pin, and not just have them VCC power. We could have them as well just down here like this, but that doesn't give you an idea of where do you actually want to place these capacitors, because the power network can be fairly large. So we want to have them physically located close to these pins. The last thing we want to do is a programming interface. So we cheat here a little bit, and what we choose is the miscellaneous devices and connectors libraries. In this case, we choose the connector library, and the programming interface has 4 different pins that we want to provide. So we take a 4-port header. In this case, these will be a very standard 100 mil header. That's very cheap and very easy to get. And we place that one in the middle of the schematics or wherever you want to put them. We create again net labels for the different signals. And the 4 signals that we want to provide is power, ground, and the 2 wires for programming. So we want to go and get power, put it on pin 1, ground on pin 4, and the other 2 signals are the SBWTCK and SBW TDIO signal. Let's create net labels for these 2 signals. So SBWTCK, SBWTDIO, and net labels 2 you can just copy holding down Shift and dragging them over. This port will allow us later on to program the device. Now, as you can see, this microcontroller has still a lot of pins that we haven't used, so it would be a waste to not actually pin them out. For that reason, let's move this up out of the way. Let's copy the line. And let's add some net labels into it. And we want to also pin out the I2C over here. And we can also pin out these two lines. Okay, now again we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 new signals. So we place a port, and instead of a 4 type header, we choose a 10 port header. Place it down here. And the easiest way of copying all of this is again just a copy. Just need some lines. And this is it. That's our little schematic of our embedded system that has a push button, has some resistors, capacitors, programming interface, I/O interface for extensions if you want to, and some LEDs for showing some status. Let's save the schematic, and before we can go to the next step, what we want to do is we want to go with the tools. We want to annotate our schematic. What that means is all these question marks will actually be filled out with actual numbers. So we click on update the change list, and what you can see is that it changed and numbered the different parts with their own designators. We accept the changes, we validate them, we execute them, we close it, and as you can see, there are no more red twiddly lines around. All the different parts have now different numbers, and this is how we need the schematics to be. Of course, you can also now add down here a title, you can add the number, revision, etc., etc. You can all do this all by just manually going into PT. So you can add in a text string here, you can say this what revision this was. You can add the author on who made this, you can add different symbols. Or you can go right-clicking onto options, and to the sheets there's different parameters that you can set in here, where if you fill this out, parts of it will be automatically filled out in here. So for example, if I go into the title and I say this is homework 1, occasionally it shows up in here if there would be the right title string done down here.